Today we're going to be working on quiz 16 from spring 2018. Given at the origin when t equals 0, h naught is -5 in the y direction, amps per meter in a vacuum. The electromagnetic wave is in left-hand circular polarization with the wave vector k of 3x minus 4z. What is the corresponding E field? So first, you draw the axis. And since we're given x and z, I'll call this my x and this my z. We know x is here and z is here because if we use the right hand rule for axes, we know that, or if we put our right thumb to the right, this is our x axis, and our right index finger pointing up is our y direction, and our middle finger pointing towards us is our z direction. So if we move our hand so the x is pointing to the right and z is pointing up, we see that y is pointing into the board. So we know positive y is into the board. And we're given the wave vector of 3x minus 4z. So 3 and 4 over here, that's our k. And we know h is in the negative y direction. And since we said positive y is into the board, the negative y will be out of the board. So h is out of the board. Using the right hand rule, if we point our thumb in the direction of k and we curl our fingers in the direction of h, which is out of the board, when we straighten out our fingers, that will be the direction of E1. And when we straighten our fingers out, it will point in this quadrant right here, quadrant 1. And so that would be 2, 3. Our x is going to be 4 and our z is going to be 3. That is because the angle between these two is 90 degrees, and this is our alpha. And tangent of alpha would be 3 over 4, because tangent is opposite over adjacent. And so this is our alpha here. And the angle between these two is also 90. This would be our alpha, so tangent of alpha would also be 3 over 4. So that's why, in order to satisfy this, it's pretty much the opposite of what we did for k. And since for k we did 3 along the x direction and 4 along the z direction, for E1 it's going to be 4 along the x direction and 3 along the z direction to satisfy this right here. Next, to figure out E2, we use our left hand because it is a left-hand circular polarization wave, and E1 cross E2 equals k. So if we point our fingers in the direction of our left hand in the direction of E1, and our thumb in the direction of k, when we curl our fingers, we see that the fingers point into the board. So that tells us that E2 is into the board, which is in the positive y direction. So we know that E1 is I just said 4x plus 3z. We're going to divide it by 5 to normalize it because the magnitude of 4 and 3 is 5. And E naught over H naught equals eta naught. And since we're in a vacuum, we know eta naught is 377. So E naught equals 377 times 5. So I'll leave this like this for now. 377 times 5. And it's going to be cosine of omega t. And we know omega equals ck. And c is speed of light, so 3 times 10 to the 8. And k is 5. So that is 1.5 times 10 to the 9. So it's cosine of 1.5 times 10 to the 9. Then our k is going to be the opposite of what we have here because of the equation cosine or sine omega t minus k dot r. And because of this minus sign right here, we're pretty much just going to switch the signs. So it's going to be minus 3x plus 4z. Now, for E2, we know that it goes into the board, which is along the y direction, so it's y hat times the magnitude, 377 times 5. And since it's 90 degrees in phase with cosine, it's going to be sine 1.5 times 10 to the 9 t minus 3x plus 4z. And all that together is the 5's cancel out, so it's 4x hat plus 3z hat times 377 cosine 1.5 times 10 to the 9 minus 3x plus 4z plus y hat 1885 sine 1.5 times 10 to the 9 t minus 3x plus 4z. And since we're finding the E field, it's going to be volts per meter. This whole thing is your E field. And there should be a T over here.